Okay, let's see if we can look at some determinants and inverses of specifically 2 by 2 matrix. And we'll start with the determinant. And this is a formula that only works for 2 by 2 matrices, but if you have a 2 by 2 with the elements A, B, C, and D here, then the determinant of that matrix A, which is generally written with just the straight vertical bars like this, is just simply this cross multiplication A times D minus C times B. And then that numerical value will just be the determinant of that matrix. So let's just do a quick example. Here you have a 2 by 2, and you cross multiply those two and you get -6. Subtract cross product of 1 times 5, or 5, and -6 subtract 5 is -11. So that's pretty easy to do for a 2 by 2 matrix. Okay, the next thing we're going to talk about are inverses of a square matrix. Well, before we talk about the inverse, I would like to make a statement that these two matrices will be inverses if we multiply them and we get this special identity matrix that has this specific specifications, where you have a diagonal of 1 running along the main diagonal, and then everything else is 0. And that holds true for a 2 by 2 or even a 3 by 3. 3 by 3 would be, the identity matrix would look like this, where you can see the 1s running along this diagonal. So that's just a special matrix called the identity matrix. Alright, well, let's multiply these two and see what we have. Remember, when we multiply matrices, we multiply the horizontal, or the row, by the column here. And the first term would be 1 times 11, or 11, plus -5 times 2, -10. And that's the first element. And then we move over, still concentrating on the first row. Now we're multiplying it to the second column. And so we have 1 times 5 and -5 times 1. So we add to it a -5. And then moving our efforts down to the bottom row, we have -2 times 11, which is a -22. We add to that 11 times 2, +22. So you can see that quantity is going to be 0. And then finally, the last column in the second matrix would give us -2 times 5, -10, plus 11 times 1, +11. And remember, this is a matrix. And so the result of that would be, if we just add those quantities up, we get 1, 0, 0, 1. So that the fact that it gave us the identity matrix back tells us that these two matrices are inverses of each other. Alright, well, let's take a look at how you find the inverse of a matrix. Well, the first step in finding an inverse of a matrix is, first you have to find the determinant. So on this 2 by 2, we'll just use our formula where we cross multiply A times D and then subtract the quantity that we get when we cross multiply C and B. So let's do that first on number 5. In this example, let's find the determinant. The determinant equals, we have -9 times -3, we get a +27. and then we subtract the quantity 6 times 5. And so the determinant of this matrix is equal to a -3. So if we look at our formula from right above us, we see that we take the determinant, take the reciprocal of it, and then we do something special to the matrix. Let me erase this here. We take and we transpose, or we switch A and D, and then we take the quantity that was B and we make it the opposite, and we do the same thing for C. Make it the opposite value. So let's see if we can set up this formula. We have -1/3. That's going to be our scalar. And we switch the first and last position. And then the opposite of +5 is -5. And the opposite of +6 is -6. Let's try that again. And we just scale it up. So the inverse of this, which is written, for instance, if this was called matrix A, this would be A inverse. -1/3 times a -3 is equal to +1. And -1/3 times -5 is +5/3. And -1/3 times a -6 be +6/3, or 2. And then we have -9 times a -1/3, 9/3, or +3. Okay, so we're going to be using inverses in the near future to solve systems of equations using matrices. So good luck with the rest of your homework on this.